Today we're going to be talking about 8.5 properties of logarithms, the objective to use properties of logs to simplify. Real life application measuring earthquake, sound, and acidity. All the examples you'll see in this video will be in your textbook. There'll be different examples shown with all the work, so you can check that out as another resource. These are the properties that you're going to see throughout this video. We're going to talk about all three of them, starting with the one that's checkmarked, the product property. If you look there, the factors U and V can be broken down into addition. We're going to talk about how that product property can be broken down and also expanded.
So if we take a look at the product property first, where we're going to start is we're going to look at log base 2 of 64. We're going to use the method, the swoop-de-loop that we've been using the last few days in class. If we were going to go through and solve this, we would say 2 to what power is going to give me 64. When we write that in exponential form, we would be here. If we look at our target card, or kind of just go through and solve this, we end up getting that x equals 6. So we're going to use that and kind of take a look at if the product property actually matches up with that, given that log base 2 of 4 equals 2 and log base 2 of 16 equals 4. All right, and then from there what we're going to do is working on the right and actually using the product property. Now, if we split up 64 into its factors of 4 and 16, what we could say, looking here, 4 times 16, is the product property would tell us that we should be able to split this up like this, because since 4 times 16 equals 64, we're able to split the two of these expressions up. Now, we know that log base 2 of 4 equals 2, as it's stated up here, so we'll substitute that in, and then we know that log base 2 of log base 2 of 16 is going to equal 4, so we substitute that in. We see 2 plus 4 equals 6, which ends up matching up with our answer using the swoop-de-loop method that we had used previously. Right, so now if we take a look at this example, we have condensed this expression. We have log base 3 of 3 plus log base 3 of 27. This is kind of going to be working in the opposite direction of everything that we had done on the last slide. But again, we'll break it up in two separate parts and just show that this property ultimately does work. If we were to look at these, log base 3 of 3, if we were to use the swoop-de-loop method over here, all right, we're saying 3 to what power is going to equal 3? That's ultimately going to be 1. Ultimately, the same thing here. 3 to what power is going to equal 27? Should be 3. So that means when we go through and we actually use this product property now, what we should come out to is an answer of 4. Now, when we get here, we have the same base of 3 in our logarithms, so we condense our expression using the product property to 3 times 27. Now we go through log base 3 of 81, and from here we could use the swoop-de-loop method. 3 to what power gives us 81? We write it in exponential form. 3 to the x equals 81. Using our target card, we can see that ends up equaling 4, which does match our example from before.
All right, so we focused on the product property. Mr. Haynes showed us that the product property does actually work. Now let's prove this idea of a quotient property. In this instance, you're going to have division within the log b, u over v. Now we're going to break that down into subtraction. So now we're focusing on the quotient property. This is an example we're going to be looking at. We have two evaluations at the top. We have log base 2, 4 is equal to 2, and log base 2 of 8 is equal to 3 to evaluate. We're going to use that to evaluate log base 2, 8 over 4. Remember, this just says log base 2, 8 over 4. Okay? So just like Mr. Haynes did, we're going to split up into 2. All right, we're going to prove that it actually does work and then show with the quotient property that we should get the same value. If you guys remember, 8 over 4 simplifies to 2, so you're left with log base 2, 2. If you refer back to your properties, when you have log with the base and the number on the inside, it's the same. We can say that this just creates 1. You could also show that using the swoop-de-loop method. Similarly, when you have division, we can break this down into subtraction. So when you have something like log base 2, 8 over 4, we can rewrite that as log base 2, 8 minus log base 2, 4. you look back up here, we have those values, all right? Log base 2, 8 is shown up here, which we know is 3. Log base 2, 4 is here, shows us as 2. We have subtraction. We should get the answer as 1. Fix that. 1. If you look here that our quotient property did actually work with showing the evaluation on the left, we do get the answer of the expanded form on the right. Let's take a look at the opposite end. Let's say we want to condense the expressions. We can definitely condense a natural log. This is our first citing of a natural log with these properties. If you look at these, remember, they don't actually show you the base. You should assume that a natural log gives you a base of e. In this same instance, we're working backwards with the property. So instead of subtracting, since we have like bases, we can actually condense this into the natural log base e of 16 over 4. At this point, you guys should know that 16 over 4 reduces 4, and we get the answer natural log base e 4. That is a condensed form of the natural log of 16 minus the natural log of...
All right, continuing where Mr. Yor left off, we went through the product property, we showed why that worked. We looked at the quotient property, why that worked. Now we're going to take a look at the last one, the power property. What that says is log base b of some u to the n is going to be equal to n times log base b of u. If you notice, we're going to prove when we have some exponent here, it's going to essentially be the same thing as moving that towards the front and then multiplying the logarithmic expression by that value. So let's take a look at this. We say log base 2 of 8 is going to equal 3, and just like what we have done already, we're going to split this into 2 separate terms. So just looking at what I had done earlier, we know that log base 2 of 64 should ultimately come out to 6. So now actually using the power property to go ahead and get the same exact answer, what we could do is rewrite that log base 2 of 64 as log base 2 of 8 squared. Now from here, we can actually go ahead and apply the power property. What that says is if we have some exponent here, we could really move that to the front and say 2 times log base 2 of 8. We go through log base 2 of 8. We see over here that that is going to be equal to 3. So we can substitute that in. 2 times 3. That gives us 6. And we see that the two of these check out. All right, the power property here indeed does work. If we take a look at another example, we're going to look kind of in the opposite direction. We're going to condense this expression. We're going to use the power property in the opposite way. We're saying 4 times log base 16 of 2. We're going to take the 4, move it into the logarithmic expression, log base 16 of 2 to the 4th. From there, we simplify that, log base 16 of 16. Now, like Mr. Yor had hit on before, when we have log base 16 and a 16 inside the logarithmic expression, the same exact number, that should reduce to 1.
So now that we have all the properties, let's put them all in together, mix them in, and solve some with variables. All right, so we're going to try and expand this natural log. We have natural log 3xy squared. If you look in between all of these values in here, we have multiplication. That should immediately tell us that we can separate this into addition. That's what the product property says. We can write this as the natural log of 3 plus the natural log of x plus the natural log of y squared. At this point, our first two pieces of the expression are simplified, but if you look at the last one, the natural log of y squared, we have our power property. Remember, instead of leaving that exponent, that 2, up top, we can bring it down to the front, meaning that we can simplify this to the natural log of 3 plus the natural log of x plus 2 times the quantity natural log of y. This is the expanded form of the natural log of 3 times x times y squared. To that effect, we only use the product property and the power property. Just like the previous example, now we can look at more properties come into play with variables. All right, here we can see that we have multiplication outside with the coefficient, so we can kind of look at that as an exponent, that 10 being an exponent that we bring over for the x. Similarly, this 2 is really multiplication out there, a coefficient that we can bring that 2 up for an exponent. That's our power property. So we have log base 7 x to the 10th minus log base 7 10 squared. That's just bringing our coefficients to the front, making them powers. X to the 10th cannot be simplified, but 10 squared definitely could be simplified. We now have log base 7 x to the 10th minus log base 7 100. The last property we have to put in play, if you looked at, we have subtraction. That should immediately tell us the opposite case of the quotient property. Instead of the subtraction with like bases, we can simplify this into division. This all can be written as log base 7 x to the 10th all over 100. That is us condensing what we initially had as 10 times the quantity log base 7x minus 2 times the quantity log base 7 10. This all can be simplified to log base 7 x to the 10th over 100. That's all the properties that you're going to see in 8.5. Remember, the examples can be seen in your textbook 493 to 494. They use some approximation instead of actual values like we did today. Make sure you go on to your respective teacher's website to complete the Google form online for a homework grade. It will be graded as a homework grade.